Welcome back to The Explainer. Today, we're jumping straight into a fascinating concept recently highlighted by Future Tech Insider. Now, at first glance, this sounds like it was pulled directly out of a science fiction novel, but it's actually the focus of some very real, very intense research. We are unpacking what could potentially be the ultimate energy innovation, space-based solar power. It's an idea that pushes the absolute boundaries of engineering and physics, and I am genuinely so excited to explore the mechanics and the massive implications of this with you.
Okay, let's dive into this. What if the world's electricity came from space instead of Earth? It's a pretty staggering, provocative question, right? We are so incredibly accustomed to digging our resources out of the ground or, harvesting them from our immediate environment. But this thought experiment challenges us to literally look up. Just imagine waking up tomorrow morning, flipping on your kitchen lights, brewing your coffee, and knowing that the raw energy powering your home wasn't generated at a local plant down the highway. Instead, it was harvested thousands of miles above your head and beamed down directly from the cosmos. It fundamentally shifts our entire relationship with how we consume power.
To really grasp how this ambitious system would work, we have to define the core concept. Space-based solar power involves leading scientists and engineers designing giant satellite stations specifically built to collect solar energy high up in orbit. Try to picture this extreme environment in your mind's eye for a second. You've got utter silence, the total vacuum of space, and massive sprawling arrays of solar panels just silently floating in the void. Up there, completely unobstructed by our atmosphere, the sun shines with this brilliant, blinding, endless intensity. It's a profound image of human ingenuity, really, taking the traditional energy-gathering methods we use here on the ground and elevating them into the harsh, yet incredibly energy-rich environment of orbit.
Now, what's really interesting about this slide is the why. Why go to all this trouble? Well, it all comes down to one simple, unavoidable truth about our planet, our weather, and our rotation. With our current Earth-based solar collection, we're fundamentally limited. We constantly have to contend with thick clouds blocking the sun, atmospheric scattering that actively reduces the intensity of the rays, and of course, the simple reality of nighttime. When the Earth turns and the sun goes down, traditional solar collection just stops cold. But by taking those giant collectors and positioning them high above the atmosphere, we completely bypass terrestrial weather. We basically enter a state of eternal noon. We unlock the unprecedented ability to generate perfectly clean energy 24 hours a day, 7 days a week, creating a continuous stream of power that never sleeps.
Let's move to the actual steps and see how this builds. Think about the incredible journey of a single ray of sunlight in this proposed system. It unfolds in 3 distinct, highly engineered phases. First, those massive solar panels collect that intense, uninterrupted solar radiation out in the bitter cold of space. Then we hit step 2, which is where the real technological magic has to happen. That raw collected energy isn't just stored in a giant battery floating in orbit. It has to be converted and safely transmitted, essentially beamed as a highly precise microwave or laser stream down toward the Earth's surface. And this entire transmission is constantly monitored by engineers to ensure complete precision and safety. Finally, large receiving stations on the ground catch this targeted energy stream, convert it back, and feed it directly into our local electrical grids. The ultimate result is bustling cities across the globe, lighting up with abundant, clean, zero-emission energy. But as wondrous and fascinating as the sci-fi vision is, we have to talk about the gravity of reality. When dealing with space technology, it is incredibly easy for all of us to get caught up in the sheer awe of what might be possible. We naturally start imagining this utopian future. But to truly understand this topic, we need to stay firmly grounded and look at the hard facts as they exist today. The research points out very clearly that there are major roadblocks ahead. Transitioning this idea from a theoretical, beautifully animated computer model into a physical, fully operational space grid is a monumental task. We aren't quite ready to plug our laptops into a space beam just yet. So the crucial point is understanding exactly what stands in our way, which explains why you aren't seeing this technology on the evening news every single day. First, we're facing engineering challenges on a scale humanity has rarely attempted. We're talking about launching infrastructure the size of small cities into orbit and finding ways to assemble these massive structures autonomously in zero gravity. Because of that, there are significant cost barriers. Space launches are still extraordinarily expensive, and funding a global infrastructure project of this unprecedented magnitude requires investment on a level we've just never seen before. Finally, we must objectively recognize that this technology currently remains strictly in the research and development phase. It's brilliant physics on paper, for sure, but scaling it up for actual, everyday deployment requires massive breakthroughs in material science and orbital mechanics that we are still actively working toward. Yet, even with those staggering practical challenges standing in our way, the potential payoff here is undeniably profound. If scientists and engineers can solve these hurdles, and history has consistently shown us that human ingenuity often does, space-based solar power acts as a potential frontrunner for the single biggest energy innovation of our future. I want you to really think about what a fully illuminated, decoupled world looks like. It means true energy abundance. It means a future where we're no longer reliant on finite, polluting fossil fuels dug from the dirt, but instead have a permanent, sustainable solution for our global power grids. Drawing infinite, clean power from the very star that gave us life would fundamentally rewrite the trajectory of human civilization and establish a truly sustainable tomorrow. As we wrap up our analysis of Future Tech Insider's fascinating report, there is one final, lingering thought to leave you with. Would you trust electricity sent from space? It's a profound question that goes far, far beyond just the physics and the engineering. It touches on our deeply rooted relationship with new technology, our psychological comfort with the unknown, and how radically we're willing to reimagine the infrastructure of our daily lives. Take a moment to sit with that idea, discuss it, and think about what it would take for you to embrace a world powered by the stars. Thank you for exploring these concepts with me on The Explainer today, and keep that curiosity alive.